what questions do you have over the review? I can hear you in this room, or you feel free to send me, oh, dang it, just a second. Send me a message like via chat. I'll have that pulled up so that I can see that as well.
You go over like the homework problems?
Sure.
The last two, it was.
I don't have them with me, but if you can tell me what they are.
I think.
Oh, I guess I could look them up also. For week 7?
And it was like something, if you roll one time and then you roll another time. Or it was a marbles.
Okay, so she is asking to go over the last 2 problems from the homework that you turned in yesterday. These two, 15 and 16?
Mm-hmm.
Okay, so we're going to go over 15 and 16 from the homework. It says, what's the probability that you draw a red marble followed by a yellow marble if the first marble is replaced after the drawing? So let me write this down on my paper real fast before I... So this is 15 and 16 homework, week 7. So there are 5 yellow marbles. There are 6 red and 4 blue. And for problem number 15, we're trying to see red, then yellow, if it is replaced. And then 16 is when it's not replaced. Okay, so here's what we have in our bag. We have 5 yellow, we have 6 red, we have 4 blue. So that is a total of 15 marbles. I guess I can get my mask off. So total of 15 marbles. So the probability of drawing a red would be, there are 6 red options out of 15 total marbles. So this is the probability of a red. And then the probability of a yellow, there are 5 total yellow out of, there are 15 total marbles, because after you drew the red, you put it back in. And we're going to multiply these. You can multiply like that, but those are gonna be big numbers. It's a little bit easier if you reduce them first. So 6/15, those both divide by 3, and you would get 2/5, right? 5/15 reduces to 1/3. Oh. And then you just multiply across the top, across the bottom. So 2 times 1 is 2. 5 times 3 is 15. So that's the fraction 2/15. And then you can make it into a percent by finding the decimal first. So 2 divided by 15. The decimal is 0.133 repeating. And for the percent, you move the decimal place over 2 times. So you would get 13.33%.
So if we only did 13.3, would that be still the right answer?
Yeah, that's fine.
Okay.
Let's see if I can make this to where we can kind of see all of it at the same time. Okay. Kinsey, I have your questions. Give me a second and I'll get to them. Let me finish these 2 first.
Okay.
Okay, so for number 16, it's the same problem. We're just not replacing the red. So we're still doing a red, then a yellow, if red is not replaced. And let me verify that's the question. Let's see. Red, then yellow, if the red is not replaced. Okay, yes. All right. Okay, so the probability of the red's still the same. There's still 6 reds out of 15 total marbles. The probability of the yellow is different this time. There are still 5 yellow marbles, but this time we drew 1 red already, so there's only 14 marbles in the bag to draw from.
Oh.
So this is the probability of the yellow. I'm gonna go ahead and reduce that first one before I multiply. So this would be, again, 2/5 times 5/14. And you would get 10/70. And that reduces to 1/7. So that's the fraction. And then the decimal would be 0.1429. And then for the percent, when you move it over, it's 14.29%. And it should kind of make sense that there's a higher probability of it happening if you don't put the red back versus when you do, because there's less marbles to choose from down here. I mean, it's not that much difference, but it's a little bit different.
It's a little bit. Okay.
Does that help?
Mm-hmm.
Okay, so we want to go over let's start off with number 2 on the review. So number 2 on the review says a football quarterback has passed the ball for 23 touchdowns in the last 17 quarters. Use a proportion to determine the following. At this rate, how many touchdowns to the nearest hundredth would he throw in a normal 4-quarter game? So they told us 23 touchdowns in 17 quarters. I'm gonna put a Q just for quarters. And then we are trying to figure out how many touchdowns, that's what we're looking for, in a normal 4-quarter game. Okay, so for this one, usually what we do is we see 17 times what equals 4. You could technically do that. It would be a decimal, and you could multiply the decimal on top there. You could also do what we've been doing with the percentometer one. If this is like X, we could like cross multiply, do 17 times X and 23 times 4. So 17 times X would be 17X. 23 times 4 would be
92.
92, thank you. And then to solve for X, divide both by 17, and we get 5, it said nearest hundredth, so 5.41. So 5.41 touchdowns. If you wanted to do that one multiplying by the number you're multiplying by would be 4 divided by 17. Like that's a big old decimal. That's the number you're multiplying by on top and on bottom. And you should get the same number there, but it's easier to do it this way, just since it's a decimal. Okay, that's number 2. For number 5 is the next one. It says, suppose a flower bouquet has 13 roses in it and 9 carnations. So 13 roses per every 9 carnations. It says if you take away 4 roses and 4 carnations from the bouquet, does the ratio increase, decrease, or stay the same? So I'm comparing this ratio to the ratio when I take away 4 from each. So 13 minus 4 would be 9 roses. 9 minus 4 would be 5 carnations. So I want to compare these two. Are they equal? Is one bigger than the other? Is one smaller than the other? Okay, so it's kind of hard to compare 2 fractions, especially that don't have the same denominator. So there's a couple ways you could do this. You could make these have the same denominator, like get a common denominator, and then you can see which one is the bigger fraction. You could also make it into a decimal. So, or find, it's essentially like the unit rate. So if I did 13 divided by 9, that's 1.4 repeating roses per carnation. So there's technically like 1.4 roses for every 1 carnation we have in this ratio. Okay, on the other side, 9 divided by 5 is 1.8. So there are technically 1.8 roses per every 1 carnation here. So you can see, so the question asked, did the ratio increase, decrease, or stay the same? Well, we started off with 1.4 and went to 1.8, so it increased. It should never stay the same. If you subtract a number on top and subtract a number on bottom, it will always either increase or decrease. It just depends on the situation. The next one is number 8. So for number 8, it tells us that there are 8 chips in a set. So I'm just going to draw 8 circles to represent my chips. It says that there are 8 chips in the set, represent 225% of the set. So this, that it gave me the 8 chips, that is 100%. So if I want 225%, I need to put another 100% on there. So I'm going to draw 8 more chips. So that's another 100%. So now I have 200%. And then to find 25%, 25% is the same thing as 1/4. So 1/4 of this set, you could think about like splitting it into 4 parts. So I would draw 1/4 more. That's my 1/4 more. That's 25%. And so altogether, this is 225%. So it would be 8 plus 8 is 16, 17, 18 chips. And that would be a sufficient picture. Like as long as you just label the percentages, that would be fine. Sorry. Come on. Okay, so for the next one, number 12, let's look at that one. Okay, so for this one, this is the lesson with the pie chart and the bar graph and the, what else? Frequency distribution. What else do we do? Line graph. I think that was all the ones y'all did on your homework, right? Let's see, I have it pulled up
Like
right here.
histograms and stuff?
Yeah, it's on this homework right here. Pictograph, bar graph, pie chart, histogram, line graph, yeah. And just a reminder, frequency distribution and pictograph is the same thing. We talked about that a little bit in during the lesson. Pictograph is the same thing as a frequency distribution. You just use pictures on a pictograph and you use tally marks on a frequency distribution. Okay, so let's just do a quick problem. I'll give you, let's do some data. I don't know, let's say favorite animal. So people's favorite animal. So let's say we have cats, we have dogs, and we have, I don't know, a bird, I guess. And let's say 8 people like cats, 10 people like dogs, and 2 people like birds. So for a frequency distribution would look pretty much like this. It's just we would have tally marks. So you'd have cats. This is the frequency distribution. Dogs and birds. So there would be 8 tally marks here. 4, 5, 6, 7, 8. 10 tally marks here. And 2 tally marks here. If you wanted to make that into a pictograph, you could draw little smiley faces for each person or something like that. For a bar graph, you could do a horizontal bar graph or a vertical bar graph. For some reason, I like vertical better. I don't know why, but that's what I usually do. So we have cats, we have dogs, and we have birds. 8, 9, 10. Okay, and this would be the number of people over here. This would be your favorite animal on bottom. So for cats, we said 8 people like cats, so you would draw a bar up to 8. For dogs, we said 10 people like dogs, so we draw a bar up to 10. And for birds, only 2 like birds, so you draw a bar up to 2. A histogram is similar to a bar graph. The difference is a histogram usually has a interval of numbers on bottom. So I think the one we did in class was like salary or something. So like average salary. So we had like 0 to 25,000, 25 to 50, 50 to 75, something like that. So you can't really do a histogram with this one very well because it's I don't know. It is not really like you need numbers on both parts here for a histogram. Okay. Line graph, we could do a line graph with this one. It would look very similar. I would have a dot here, and a dot down here, and you would put a line here. Again, it doesn't really make sense with this set of data. But the pie chart, let's do that one because that's the hardest one. So for a pie chart, you have to find the percentage of each. So cats were 8 out of a total of, there's 8 plus 10 plus 2, so 20 total people did it. So 8 out of 20 said they liked cats, so that would be the percentage of 8 divided by 20. 8 divided by 20 is 0.4, and we make it to a percentage, it's 40%. Dogs was 10 out of 20, which I hope you can see that's 0.5, which is 50%. And so birds would be 2 out of 20, which is 0.1, which is 10%. And so when you go to draw your pie chart, you're drawing a circle. 50% is dogs, so split it in half, and that section is dogs. 40% would be the majority of the other section, it's cats, and then the small section would be birds.
Does the pie chart have to be like exact, like perfect?
No.
And
No, but like if you put it right here as cats like right here, obviously that's not 40%. But no, just as long as it looks pretty close to good, then you're fine.
okay.
Kenzie, did that answer your questions?
Yeah.
Okay. What other questions do y'all have? We already did that one.
So on the homework for week 6, I have it like right here, but I can read it out loud if you don't have it. But like on number 52, whenever they were comparing the difference with Lewis and Martin, and I'm just curious how Martin's his flavor was stronger.
Let me pull it up. I don't have my book with me, but let me pull it up. I can run and get my book if I need to. Let's see. That was week 6 homework you said?
Yeah, week 6.
Okay, let me go to, because that won't have it on there. Let me see.
Also on the review, I'm at number 6. I was reading the number and
Okay.
it has an 8 in it.
Give me a second, I'll do that one. What number did you say, 52?
It was number 52. 5. It's the one that's page 260 through 263.
Okay, let me see. I am the rest one, let's see. Week 6. Assignments. No, not that one.
Yeah, it's that one. It's on number 52, I think, or 50.
51?
Here, let me. It might be week 5.
Week 5? Okay, let me look there. All this stuff is in my way, I can't see. Okay, there we go. Let's see, week. Oh, the ratio problems is that one? Oh, that works too.
Yeah,
Oh, there we go. Martin. Okay. Do you by chance have your book with you? No. Does somebody have a book that you can show me, or I can go run down my office? It'll just take me like 2 minutes to run down there and run back.
I have mine right here, but I know it's not in person, so.
Let me run to my office. Give me like 2 minutes and I'll run down there. Sorry. I should have been more prepared. Okay. I got it. Okay, so this is the unit rate problem. So this is week 5 homework. And it's number 52. So it says that Lewis, sorry, my breath, makes 6 ounces of cherry syrup with 53 ounces of water. And Martin mixed 5 ounces with 42 ounces of water. So 5 ounces of cherry with 42 ounces of water. And we are trying to figure out who has the stronger cherry flavor. So stronger cherry flavor would be more cherry per water, right? So if you divide this out and get a unit rate, let's see, sorry, I'm gonna pull my calculator. So if I did 6 divided by 53, I get this decimal of 0.113, and it's that much cherry per 1 ounce of water. Because the denominator here is 1. So it's 0.133 ounces of cherry for every 1 ounce of water. We're going to do the same thing with Martin. 5 divided by 42 is 0.119 ounces of cherry per 1 ounce of water. So now we can compare these since they're both over 1 ounce of water. Obviously Martin's is the bigger decimal. It's not by much, but it is a little bit bigger. It's a bigger decimal, so he has the stronger cherry flavor. Does that help?
Yeah.
Okay. What else?
Number 6.
Oh yeah, number 6 on the review.
Yeah. Nothing great.
Okay, so on number 6, it says Judy received an 8% salary reduction this year. Her current salary is $41,731. What was her salary last year before she got the cut in pay? So I would do a percentimeter on this. I just really like those. It makes sense to me. So we have 0% and 0. This is 100%. Okay, so we are trying to find her salary before her pay cut. So that's what we're looking for is 100%. I'm trying to figure out what 100% of her salary is. We know that she got an 8% salary reduction. So this salary of $41,731 is what percentage of her salary? They took off 8%. So it's 92%. Does that make sense?
Yeah.
Because she's not only earning 8% of her salary, she's earning her whole salary, take away 8. So 100 minus 8%. So she's earning right now 92% of her salary. And that amount is the $41,731. So then you could set up a proportion from there. 92 over 100 equals $41,731 over, I'm trying to find that number.
So if it's 92, so then if it says percent, so like we just have to figure out where it is on the line, so that, but we can't use the 8 over 100. That won't get the accurate math right.
The math would not be right if you put 8 over 100. And the reason why it's hard is because you don't know what the 100% is. Like if you knew the full amount of salary, you could take away and say that was 8%. So, but you can't do that. They gave you an 8% reduction, which is 100 minus the 8%. Okay. So when we work this out, we get 92x equals, let's see, 4173100, which is 4,173,100. Divide that by 92. And from there, let's see, 4173100, 92. I got $45,359.78. And you can check your work here. If I took off 8% of this, like if I found 8% of this, that would be, so multiply that by 0.8. 8% is that number, $3,628.78. So 8% is 3628.78. That's where they're taking off of her salary. So if I did my original salary, 0.78 minus the 8% they're taking off, I should get what I started off with, which you do. Not we, sorry, her reduced salary, which is the number they gave us in the problem.
So 45.
Yes, that's what this number is right here. This is $45,359.78. That was her salary last year before she got the pay cut.
Aren't these problems in the book, like the problems on the homework that we had, like this?
What else?
I have on the same week whenever I asked number I got the answer wrong, and I was wondering with the other way how you got 42.
What problem was that?
Number
14. Is it 14 on the same page or the same section? Let's see. The problem with the dosage.
Yes.
Okay, let's look at that one. So this is week 5 homework number 14. Oh, sorry, let me put my paper back up there so you can see it. There we go. Week 5 homework number 14 says.
I actually wrote down the milligrams wrong. I wrote down 6.5 and not 6.8. So that might be wrong.
There you go. Do you still want to work it out?
Yeah, I can. No, I can. I know how to solve it now. I wrote
down. Asia, do you want to work that one out? Okay, we're gonna go ahead and work it out because Asia wants to. So it says the recommended dosage for a particular medication is 6.8 milligrams per pound of body weight per day. So for every 1 pound of body weight. And you can't exceed 1,000 milligrams per day. So for a 125-pound patient, what should the dosage be? So to get from 1 to 125, I multiply by 125. I have to do the same thing on top. So 6.8, let's see. Come on, calculator. There we go. 6.8 times 125 is 850. So you would have 850 milligrams would be the dosage.
Why don't you cross multiply?
You could cross multiply that if you wanted to. If you did that, you would do 1 times x. If I put this as x, that would be 1x equals 6.8 times 125, which is 850. It's the same thing.
And then is there like another, like after you get 850, is there another way you have to get the answer? Because you wrote down 48 daily doses.
What would you expect to the doctor recommend for a daily dosage? I think that's the answer, right? Let me see. Let me look at the solutions.
Yeah, just 40. Oh, there we go. Okay, 850. Never mind.
You're good.
All right, I don't know where I was thinking that stuff.
Make sure, so I'm just kind of looking over the problems we haven't gone over. Make sure you know, let's see, number 7, we did the reflection over that one. And I feel like everybody, like as I read the papers everybody wrote, it seems like you understand that problem pretty well. So make sure you know how to do that problem. Number 10 and 11, that's the mental math. So that's the one where you're finding the pieces and adding it together. Like you're not just typing it in your calculator to get the answer there. So like for 11, to find 325% of 60, you would find 100%, 100%, 100%, add all three of those together. And then you can do, if you know 25% of 60, you could do that, or you could do like 10%, 10%, 5%, something like that.
So like number 8, like we just did.
Kind of, yeah, but instead of having like to draw it out, you're just doing the part on the number.
Okay.
So that's for 10 and 11. We already did 12. For 13, y'all just turned in your homework over that. So I think that's pretty fresh on your mind. But make sure you can do all of those. And I noticed that I'm glad you asked the question on the homework, Asia, because I noticed I didn't put one that had the two things, like do something and then do something else after that, where you multiply the two fractions together. So here's some good examples that we did at the beginning of the video on homework 7. Make sure you can do those also.
You said on number 13.
Yeah, on number, like, those are all the odds of the different things.
Oh.
So for here, make sure you can find the odds of, those are called independent events. So for example, if you wanted like an example, the odds of drawing a red card, putting it back, then drawing a black card. I don't know. Something like that. Or what's the odds of drawing a king, putting it back, and then drawing a jack, or I don't know, a face card and a number card or something like that. And here is the difference between theoretical probability and empirical probability. Remember, theoretical is in theory, what's the probability? So when you flip a coin, it's 50% every time, in theory, if you don't actually flip the coin. Or drawing a, you know, a one of diamonds. There's only one of those cards in the deck, so it's 1 out of 52, whatever that percentage that would be. That's the theoretical probability. Empirical probability is actually performing the experiment and like seeing how many times you got heads out of how many times you rolled or flipped the coin or whatever. And when is it most likely to be the same number? That's what we talked about, the law of large numbers. So the more times you perform the experiment, the closer the empirical data gets to the theoretical data. Y'all have anything else? Okay, so to study for your exam, obviously look over these reviews. Also look over all your homework. And I showed this earlier. A couple of you have joined since then. So just a reminder that I posted, I've been posting all the homework solutions in this folder called homework solutions. And I realized last night that it was not visible and y'all weren't able to see it. So I fixed that last night. So you should be able to see them here. I also just graded your candy quiz, that Candy Jolly Ranchers Jawbreakers thing. I just graded that this morning and I'll post the solutions here. I'll do it this afternoon, post the solutions here for that. And I'll post week 7 homework solutions also. So if you there should be nothing on your test that's not posted, like that you've already done problems for or you already have the solutions for. Okay, if y'all don't have any other questions, then we will stop here. If you do have other questions and you're watching this video later, feel free to email me any questions you have. And again, your exams are on Wednesday, Thursday, and Friday this week. You signed up for them already, and I am posting them for that exact time. If an emergency happens and you got to change your time, that's fine. It's just best if you do it as soon as possible, because that was the problem last time, was people were changing their times at the last minute and then we couldn't get the information in, and Zoom calls and all that kind of stuff. So if you are going to change your time and because of an emergency, let me know as soon as you can so that we can get that figured out. Okay, y'all have a good day. Let me know if you have any questions.
Thank you, Ms. Lee.
You're welcome.